state two reasons why most of the world's energy consumption is provided by fossil fuels. These are things like coal, oil, natural gas, and so forth. Now, the reason why they are is because they're the most convenient. They are widely available. There is a lot of them, and they're easy to transport. It's easy to ship them or to take them from one place to another. We've got gas pipelines and so forth. So, widely available, great deal available, easy to transport. Another reason for it is that the power stations can be built close to the sources. So because we're able to transport electricity quite far, you can put the power stations close by, and they are of a high energy density. So I don't really feel like writing anything there. I hope you got all of that. Let's just say it again. They are widely available. There is a great deal of it. We have a lot of it at the moment, and it's easy to transport. They have a high energy density, relatively high energy density, and you can build your power stations close by. So a power station has an output power of 500 megawatts. That means 500 times 10 to the 6 joules every second. That's the amount of energy that is putting in, and an overall efficiency of 27%. So that's the amount of energy that you're putting in. Only 27% is being converted into that. 27% of the total energy coming in. It uses natural gas as the fuel and has an energy density of 56 megajoules per kilogram. So in defining energy density, well, they basically told you that it is the energy per unit mass that the fuel contains. So it's the energy that can be obtained per unit mass, as here, joules per kilogram. That basically gives it to us. Okay, so here we have question 2. Determine the rate of consumption of natural gas in the power station. Okay, so we see here that every second we are getting 500 times 10 to the 6 joules per second. All right, now how much natural gas are we going to need to get that? Knowing that only 27%. Only 27% as actually gets transferred into that 500 times 10 to the 6 joules per second. So we've got 56 times 10 to the 6 joules per kilogram, and if we multiply that by 0.27, we will get the amount of energy per kilogram that actually gets used. So if we multiply that by 56 to the 6 times 0.27, we get this amount over here. It's 1, 2, 3, 4, 5, 6, 7. It's 1.512. I'll keep it as times 10 to the 7 joules per kilogram. Alright, that's the amount. Now we need that many 500 times 10 to the 6 joules per second. So I must divide it by this value. So we're going to get 500 times 10 to the 6 divided by 1.512 times 10 to the 7, and that will give us the number of kilograms, because you see we've got the joules per second, and the joules, they're going to cancel out, and we're going to get a kilogram per second coming out of this value. Well, let me just put that in. As you're going to have a joules per second here and a joules per kilogram. When I divide that, our joules will cancel out. Our kilogram goes to the top, becomes just kilograms, and we'll get a kilograms per second, and that will be a rate of consumption. So it's 500 exponent 6 divided by my answer, and I get about 33 kilograms per second. Now, just let's look at our number of decimal places here, number of significant figures. Here I've got a 56, 27, 500. I think the 33 is sufficient there for the number of decimal places. Question C. Outline why the enhanced greenhouse effect may result in an increase of temperature of the Earth's surface. Now, what happens with the enhanced greenhouse effect, as we've discussed before, is that your energy comes in from the sun and it is absorbed by the Earth. So it's absorbed by the Earth, and then re-radiated as infrared radiation, IR, infrared radiation. It's a longer wavelength, and this gets absorbed by the greenhouse gases. Greenhouse gases. Let's put a GHG there. Now, the atmosphere will then re-radiate that energy, and therefore heat up the Earth. Heat up the Earth further. So that's why when you have a cloudy day at night, temperature doesn't drop so much, because the energy is absorbed by the water vapor, and that re-radiates it and heats up the Earth further.